And joining me now is Dr. Ofer Levy. He is an infectious disease specialist who is working on a vaccine at Boston Children's Hospital. He's also a professor at Harvard Medical School. Doctor, thank you so much for joining us.
My pleasure.
It's obviously we want to hear a lot about these vaccine efforts. I want to talk first briefly on the fact that since we don't have a vaccine and we're seeing the president pressuring to reopen the economy, there's this question of what happens if you reopen it too soon without a vaccine. What does that look like?
Well, first of all, let's identify the deep desire of probably every American to get back to some semblance of normalcy. So that's very understandable. That said, the virus is out there. There's still a lot of susceptible people out there. We don't know exactly the proportion, but there are many. And if you reopen too soon or without careful consideration to how you reopen, the risk is another huge wave of infection that could potentially overwhelm hospitals.
So we were talking in the break about this, doing fascinating work, and you're doing it basically around the clock, modeling the human immune system outside of the body for young people, for basically babies, children, for grown-ups, as well as for the elderly. Tell us about what you're looking at specifically when it comes to the elderly, because they've been so impacted by the coronavirus.
Right. Well, thank you for that, Brianna. Typically vaccine development, early on at least, disregards the characteristics of who you give the vaccine to, right? Whether it's a man or a woman, young or old. But it turns out that some of these factors can play a big role in how you respond to a vaccine. And typical vaccine development can sometimes take quite a long time. We at the Precision Vaccines Program are taking a very different approach. And we're trying to put the human aspect of the design very early in the process. And we do that outside the body. We have biobanks of white blood cells that have been donated by elderly individuals who want to support this effort. And we're able to test outside the body different types of candidate vaccines to see which may work best in that age group, because the immune system is very different in the elderly. And obviously, they're at greatest risk of severe coronavirus disease.
It's so beautiful that you have elderly Americans who are giving you those white blood cells to try to forward your research here. I wonder what you think about something Dr. Fauci said yesterday. He said he believes that a vaccine could be ready for public rollout sooner than that 12 to 18 months that we've been hearing. Do you share that optimism?
Cautiously, I do. We're very grateful to Dr. Fauci's leadership, and his National Institute of Allergy and Infectious Diseases, which he directs, is a major supporter of our research. I know how hard everyone at NIH and across academia, government, and industry in the US is working on this. We would all, listen, Brianna, we would all love to have a safe and effective vaccine as soon as possible. In fact, we'd all love to have it yesterday. The fact of the matter is, if we manage to launch a safe and effective vaccine in less than a year, that sounds like we wish we could have it even faster. But to step back a second, traditionally vaccine development has taken 10 to 20 years. We don't have that kind of time, but these are very, very fast timelines. They're basically based on using the most cutting edge technologies, having unprecedented levels of collaboration between medical centers, academia, government, and industry, which is what I see happening right now, and having this kind of concerted effort.
I want to revisit what you said about just how long this takes. Just remind us the different phases this has to go through in order to develop this vaccine, just for people at home who are wondering, why does it take so long?
Right. So to remember that vaccines have a key component. We call that component an antigen. Why? Because it generates antibodies. You inject somebody with an antigen, and their immune system remembers that. And over a few weeks, you might form antibodies against that antigen that may protect you. In the case of coronavirus, one possibility is that the antigen might be the spike protein on coronavirus. Many of your viewers have seen what the virus looks like, a ball with spikes on it. The tips of those spikes are a good protein antigen candidate, because we believe that antibodies against them will block the ability of the virus from infecting human cells. So all vaccines have some sort of antigen, but some vaccines also have a second component that we call an adjuvant. The adjuvant boosts the immune response. It's like rocket fuel to make the immune response much faster and stronger. And that might be particularly important here because even if we have a vaccine that's safe and effective, that'll be a great milestone. But remember, Brianna, we also are going to need to scale it up to hundreds of millions or billions of doses. That's far from trivial. So an adjuvant sometimes allows you to use less of the antigen, which is the expensive part, and an adjuvant lets you boost an immune response so that a population with weak immunity, such as the elderly, may respond better to the vaccine. Finally, the adjuvant may allow the response to last longer so that if you do form an antibody against the coronavirus, it'll last for longer and you don't need as many doses of vaccine. So for all these reasons, we think that adding an adjuvant might be an important part of the ultimate solution here for an effective coronavirus vaccine. But the thing is, Brianna, that adjuvants have different effects sometimes depending on the age of the individual. And that's where our precision vaccines program is modeling which adjuvant might look best in the elderly.
Yeah, you're taking care of all of the groups here, especially our elderly. Dr. Levy, thank you so much for walking us through all of this and just taking us inside of the work that you're doing. Dr. Ofer Levy, we appreciate it.
Thank you so much, Brianna.